Happy Monday, everyone. Hopefully, you had a great weekend, stayed safe out there, kept those hands clean. Today, we're going to be talking about mechanical energy conversions. Basically, how fast is something going if you let it go from a certain height, or how high does it go if it was going fast a certain height and then goes uphill or straight up into the air? We've done this before with kinematics, and I think you'll see that the numbers will come out the exact same. But what's so nice about using energy rather than 1/2 AT squared or V squared equals VI squared plus 2A delta Y is that we don't really care if it goes in a straight line. Energy is conserved no matter what path the object takes. So whether it's going up a ramp, down a slide, around a corkscrew, none of that matters. We can still figure out the velocity without having to worry about all the angles that result from all of that. So let's start with a pretty basic example. Here we have a watermelon being dropped from the top of a 50-meter tower. I think they were trying to show the usefulness of Line X truck bed liner or something like that. But we're just worried about the watermelon. So the watermelon is being dropped from 50 meters high. So what type of energy does it have when it's first let go? Well, that would be potential energy, because potential energy is the energy of height, specifically gravitational potential energy. What type of energy does that energy convert to as it falls? Well, it's losing height, so it's losing gravitational potential energy, and it's picking up speed, and the energy of speed is kinetic energy. What's the relationship between the amount of potential energy it starts with and the amount of kinetic energy it ends with? They have to be the same, because the kinetic energy came from the potential energy. And as the watermelon reaches the ground, all that potential energy is going to be gone, which means it's all turned into kinetic energy, assuming there's no air resistance here. So we can figure out how fast the watermelon will be going when it reaches the ground. First, by saying all the potential energy from the beginning will turn into kinetic energy in the end. As it loses potential energy, it's picking up kinetic energy until there's no potential energy left and just kinetic energy. We can now write in those formulas. Gravitational potential energy formula is mgh. Kinetic energy formula is 1/2 mv squared. We're just replacing GPE with mgh and KE with 1/2 mv squared. You'll notice there's an m on both sides. Is that the same mass? Yeah, it's the mass of the watermelon, right? So let's just eliminate that m and plug in our givens. Gravitational acceleration is 10 and the height is 50 meters. We have the 1/2 on the other side, and we're solving for the velocity. So 10 times 50 is 500. 500 divided by 1/2 is the same as multiplying by 2, so we get 1,000 equals v squared. The square root of 1,000 is 31.6 meters per second. Good. This man is going down a water slide. Let's take a look at it first. He's going from a higher point to a lower point. Therefore, he is losing potential energy. That's the type of energy he started with. And as he goes down, he's going faster and faster, which means he's gaining kinetic energy. So we want to find out how fast it's going to the bottom of the slide. So let's write our equations out. The gravitational potential energy he starts with is going to be equal to the kinetic energy that he ends with. That's because he's gone down completely. If we were halfway down, then he'd have half the amount of potential energy and half the amount of kinetic energy, right? Because energy is conserved. So let's write in our equations. The potential energy is mass times gravity times height, and kinetic energy is 1/2 mv squared. We can eliminate our masses, just cross those out, and we're left with a gravity of 10 and a height of 4 equals 1/2 v squared. Do a little math. 10 times 4 is 40. Multiply both sides by 2 and we get 80 equals v squared. Get the square root of both sides and we get 8.9 meters per second. Third, we have a car that is running out of gas just before it hits a hill. So it's moving along at some speed, 18 meters a second, and then it gets to the hill, and without any power, it's going to go up the hill due to inertia. The question is, how far up the hill does it go? Well, in this case, we're going from kinetic energy, because it was moving, to potential energy, because it's getting higher. So let's write in those equations. And then let's cross out our masses because they're on both sides. So 1/2 v squared equals gravity times height. And let's plug in the velocity, which is 18, and the gravity, which is 10. 18 squared is 324. Remember, we need to do that first due to order of operations. Then we can get 1/2 of 324 is 162. Divide both sides by 10 to get that h alone, and we get to 16.2 meters high. Any questions?